Okay, so computer science. Sounds kind of dry, right? Like textbooks and boring lectures.
Maybe.
But trust me, the history of this stuff, wild.
Oh, yeah.
We're talking crazy inventions, brilliant minds. Seriously, folks, people were building computers centuries before electricity was even a thing.
It's true. The urge to compute, to solve problems,
Right.
it's basically human nature, right?
Right. And to prove it, we've got a whole stack of excerpts, articles, all about the history of computer science.
Fun stuff.
And our mission today, not just a boring timeline. We want to figure out, how do we get from, like, counting beads on an abacus,
Which most people have at least seen.
yeah, to the phone in your pocket? And more importantly, what does that tell us about the future?
Okay, so first thing to get. Computer science isn't just coding.
Right.
It's about solving problems. The abacus, that's a perfect example. Moving those beads around, that's computation. Manipulating symbols to get an answer. Been doing that forever.
So, humans, problem solvers by nature. But then comes this guy, Charles Babbage, 1800s, designs this thing called the difference engine. Huge, all mechanical, beers and livers.
It's wild when you see pictures of it.
Totally. So what was the point of that thing? What
Okay.
problem was he even trying to solve?
Okay, so think about ships back then. Needed accurate tide tables to navigate, but calculating those by hand, ugh, nightmare.
Yeah, I can imagine.
So he designs a machine to do it, make navigation safer, more efficient.
So even back then, computation was tied to real-world stuff.
Oh, absolutely. And then, boom, the Industrial Revolution hits. Changes everything.
Right, huge changes. How did that impact computers, though?
Well, two ways, really. One, all these new problems pop up. Engineering, factories, even finance need faster calculations.
More problems need more solutions.
Exactly. But the Industrial Revolution also gives us the tools to build more complex machines in the first place.
Ah, so it's like a feedback loop.
Yeah, the problems and the solutions pushing each other forward.
Okay, so we've got the machines, but what about the people? We can't talk about this stuff without Ada Lovelace,
She's amazing, right?
first programmer. But that doesn't really cover it.
No, way too simple.
What was it about her thinking that was so ahead of its time?
So she looked at Babbage's machine, but she saw beyond it. Like, she got that it wasn't just about numbers.
Interesting.
It was about manipulating symbols, following rules, what we now call algorithms. That was huge, that insight, even if the tech wasn't there yet.
Wow. Okay. Fast forward a bit, World War II, obviously a terrible time. But it also seemed to push computing forward really fast, like the Enigma code breaking, Alan Turing.
Right, and John Neumann with computer architecture.
Is it always crises that lead to these big tech jumps?
I mean, it definitely focuses things, but the building blocks were often already there, you know?
So it's like existing trends, but sped up.
Yeah, exactly. And don't forget, Turing and von Neumann, they did different things.
Good point.
Turing, he was the code guy, the logic. Von Neumann, he was about the hardware, the physical machine. Shows you how many different skills you need to move the whole field forward.
Absolutely.
Yeah.
Okay, speaking of game changers.
Yeah.
The transistor seems so tiny, but it revolutionized everything.
For real. Imagine going from, like, horse and buggy to a car.
Okay, I'm listening.
Before transistors, it was vacuum tubes. Big, clunky, inefficient. Transistors.
Yeah.
Tiny, fast, reliable. That's what made computers smaller, cheaper, so more people could use them.
Ah, the personal computer revolution. So not just in labs anymore. How did that change how people thought about computers?
Well, before it was like this mysterious expert thing. Suddenly anyone could learn to code, make software.
Democratization of technology.
Exactly. Explosion of creativity. But new problems too, like interfaces had to become user-friendly. If grandma's going to use a computer, it can't just be lines of code on a black screen.
Yeah, true. And the software itself had to change, right? Early coding sounds like it was super manual.
Oh yeah, almost like crafting each line.
Why did that have to evolve, and is it still changing today?
Well, as software got more complex, you needed better ways to build it. Teams, not just individuals, working on huge projects, new languages, new ways to manage the whole process.
Wow, so much behind the scenes that we don't even think about.
And yeah, it's still evolving. Think about how complex software is now. It's like constantly pushing the boundaries of what's possible.
Right. And then, of course, there's the internet. Went from this niche academic thing.
To basically running the world, yeah.
Looking back, it seems inevitable, but was it?
Not at all. So many decisions, different paths it could have taken, competing networks, arguments about how to govern it, even if it should be public or private.
So many what-ifs.
Exactly. Shows how hard it is to predict the future of tech. Even the experts get it wrong.
Makes you think, And it's not just computers and the internet anymore. Computer science is a tool in, like, every field now.
Yeah, it's pretty amazing.
Decoding DNA,
Yeah.
simulating climate change, designing new medicines.
Computational thinking. It's powerful stuff. Breaking down problems, using algorithms to solve them. That's useful everywhere.
Mind-blowing. So, from counting beads to, like, the frontiers of science.
What a journey.
What's next? Where does computer science go from here?
Ooh, good question. We're at this crazy point. AI, quantum computing, stuff that sounds like sci-fi, but it's real. Limitless possibilities.
Well, like you said, hard to predict.
Yeah, that's the fun part.
Well, folks, we've gone from the abacus to AI. What blew your mind today?
Yeah.
Ada Lovelace's vision, the evolution of coding, whatever it was, keep exploring, keep asking questions, and who knows, maybe you'll write the next chapter.